Hello, I did problem 15 from module 10, Oscillations in Waves. So the question states, a pendulum has a period of 1.8 seconds on Earth. What is its period on Mars where the acceleration of gravity is about 0.37 that on Earth? So I drew Mars and a beautiful Earth and a pendulum, and we're looking for the period t. So we know the pendulum period equation, time equals 2 pi times the square root of length over gravity. And length is referring to the length of the pendulum. So since we know the period on Earth and we know gravity on Earth, it'd be easiest to find the length while we're on Earth. So gravity on Earth is 9.8 meters per second squared. Oops. And our pendulum time on Earth is 1.86 seconds. So if we put this into our equation, we got 1.8 seconds equals 2 pi times the square root of length over 9.8 meters per second squared. We can rearrange this problem so we can have it in terms of L. So if we rearrange it, we get L over 1.8 meters per second squared equals 1.86 seconds divided by 2 pi squared. If we solve for this right here, we get 0.2944 squared. And if we square that, we get 0.08669. And to get L by itself, we just multiply the gravity to our constant here. So 0.08669 times 9.8, and we get the length, which equals 0.849 meters. So now we have the length of the pendulum, and we know that the gravity on Mars is 0.37 that on Earth. So if we take 0.37 times by the gravity on Earth, we get the gravity on Mars, which is 3.626 meters per second square. So now we just substitute all we know into a problem for Mars. So on Mars, we don't know our time, so we do 2 pi times the square root of our length, which is 0.849 meters, over our Mars gravity, which is 3.626 meters per second squared. And if we solve for this right here, we get 2 pi times 0.485. And now if we just times all this together, we get 3.05. And the equation wants us to round to two significant figures. So our time will be 3.1 seconds. So the pendulum period on Earth is, on Mars is 3.1 seconds.